Okay, here's the homework problem we didn't get to due to all the coughing in class. Um, the Norman window problem. You know, you remember the one when everyone was blowing their nose and we had to keep pausing? That one. Let's say we label this. It's a rectangle with a semicircle on top of it. We know the perimeter is 20 feet, okay? So the radius of this circle would give us a width of the rectangle here of 2r, okay? Because the radius of the diameter of the circle is equivalent to the width of the rectangle. And then I'm just going to call the height of the rectangle h. Now, we know that the circumference of a circle is 2 pi, can be found by 2 pi r. But we have a semicircle, so we're going to cut that in half. So our circumference is just pi r, okay, because we only need half the circumference. So the perimeter of this entire figure can be found by taking pi r, adding 2 h's, and adding 2r, which is on the base of the rectangle. So I have 2r, h, pi r, and h. And this has to equal 20, okay? Because that's our perimeter that they gave us. So this whole thing right here represents our perimeter. Now, they want us to maximize the area. So the area of a circle is pi r squared, but I only want half of it. So I do 1/2 pi r squared, okay? And then the area of the rectangle would be the 2r base times the height. So I get 2r times h. So this is the formula we're going to use to find the area. Now the issue, like a lot of the problems we've done in class, is that I have everything in terms of r and h, and I want everything in terms of the same variable. So the first thing I got to do is go back to this original equation with the perimeter and solve it for the letter h, okay? So I am going to move the 2r and the pi r to the other side. So I would get 20 minus pi r minus 2r equals 2h. And then I'm going to divide by 2 to get rid of the 2. So now I have h is equal to 20 minus pi r minus 2r all over 2. So now I need to substitute this whole thing in for h, okay? I'm going to erase some here so that we have room. So I need to substitute this whole thing in for h now. So I'm going to get 1/2 pi r squared plus 2r times this h, which is 20 minus pi r minus 2r all over 2. Now some things simplify here, which makes this kind of nice. This 2 out front of the parentheses will cancel with that 2. And then I'm going to distribute the r in. Okay, so all I'm doing is simplifying this. So I get 1/2 pi r squared plus 20r minus pi r squared minus 2r squared when I distribute this r in. Okay. Now I'm going to collect my like terms. Okay, so I'm going to take this down here and collect my like terms, and I will get an area function with respect to r. Let's see, my like terms, I have a 20r, there are no like terms for that. I have a negative 2r squared, but I have a negative 1 pi r squared and a positive 1/2 pi r squared. So 1/2 minus 1 is a negative 1/2 pi r squared when I combine those like terms. So this is the area function that I'm going to go ahead and use. Now let's plug this into our calculator. Okay, so now let's plug that, take a minute, pause the video, and plug that function into your calculator, just like I did here. And then I want you to set your window from 0 to 5 for x min and x max, 0 to 5, and your y min from 0 to 50, y min 0, y max 50. Just pause the video and do that quick, and then hit graph. Okay, Now what we'll do is we're trying to maximize the area, so we're going to hit second trace, choice 4 for maximum. We're going to do our left bound, and then we're going to do our right bound. Okay? And we get an x value, which in our case is r, we'll round to the nearest tenth, 2.8. Okay? So the maximum value, the maximum area occurs when r is 2.8. Now the question is asking, what are the dimensions? The final question we have to answer, what are the dimensions that will admit the most light? So they want the width and height of the window. Okay? Well, r is 2.8, and we can see the dimension over here is 2r. So we're going to do 2 times 2.8. So the width of the window will actually be 5.6 feet. Okay? Now to find the height, I can go back up to this function here that we had for height. Okay? And I'm going to plug in for r. Now be careful, don't plug 5.6 in for r. Make sure you plug the 2.8 in for r. So I would plug 2.8 in for both of these r's to solve for h, and what you'll find out is that the height is also 5.6 feet. So now we have the dimensions of our window that will maximize the area and let the most light in. In this 5.6 by 5.6, we've talked about this in class about how that square seems to be the maximum area every time. So that's question 16. And I hope everybody feels better over the weekend.